So I got cut off there from my last video. Let's go through number 6. All right, so a lot of times we want to know how many people do we need to poll? How many surveys do we need to send out so that we can be accurate with our guess on what the mean is. All right, so depending on how accurate you want to be is what the ZC is. So again, to change the problem up a little bit for you, let's say we wanted to only be 90% accurate. Well, I would look at that table on page A9, table 3B. If I'm 90% accurate, Z sub C is 1.645. So that's straight from the table. You have to go back there and look. All right, and then, what's your standard deviation? That's given in the problem. So just given right to you in the problem, 7.81. And then what is E? E is how big you want your error to be, how big of a maximum error you want. And just to go along with number 6, it says if we wish to be confident that the sample mean score is within 2 points. So you're going to have to, whoever's running the survey decides how close they want to be, how big of an error they want. And then that's what E is. And then they decide, well, how accurate do they want to be? And that's where they get this from. All right. And if you plug all those things in, make sure you do the multiplication and division first. And then, after you've done it all in parentheses, then square. That'll tell you how many people you need to send a survey to. So let me do this quick. All right, so I typed all that in on my calculator, and I got the N equals, and my calculator went away, 41.26. Does it make sense to ask 41.26 people? No. So we're going to go up to 42. If we ask more people, we're definitely going to get more accurate. So always go up here. All right, so if we survey 42 people, take that large of a sample, we know our error, our guess on the mean, will be off by at most 2 points, and we're 90% confident of that. If you look at the actual problem, it's for a 99% confidence, so a lot more confident. Well, if you think about it, if you still want to be within just within 2 points of the mean, what was the mean? 178. You still want to be within just 2 points the same way, so we're not going to go any farther either way to get more confidence, to get more accurate. What we're going to do is we're going to have to ask a lot more people, do a lot more polling, because that's one way to really increase your confidence level, is to just ask a bunch more people. All right, so in the previously I've talked about, if you want to be more confident, well, you just include more numbers in your guess. You make a longer interval. But we're saying no, we want our interval to stay the same. We only want to be off by 2. So the difference, if you still want to be off by 2, the difference between 90% confidence and 99% confidence is going to mean you have to ask a lot more people, and then you'll be more accurate. And let me talk a little bit about 8 here. I'll do one similar. This was the diameter of, what are these? Shards of clay vessels. But there's some diameters listed here, and I'm gonna alter mine a little bit. I'll just leave the decimals off. So your answers will be different when you do it with the exact values from the book. This will be similar. And Excel is a great tool to use. Use a calculator with the mean and sample standard deviation key to verify that the mean of this sample is 15.8 and the standard deviation is 3.5. Well, mine will be a little different since I changed the numbers up. But if you've looked at the Excel assignment, you can use the data and then data analysis. what do we want? Descriptive statistics. And make sure for your input, you select your range of input. And if you select a header like that, you write that the label is in the first row. Okay? And so I have a column of data, my label's in the first row. I want summary statistics and the confidence level for the mean. I'm going to put my output on the same page here. So you just click where you want it. I want my output to start in D4. All right, so it quickly finds the mean for you, the standard deviation, all that stuff. But if you're trying to compute a confidence interval, well, it looks like I had typed in the 95% confidence interval, and again, you'll change that for your problem because it says 80%. But if you, let me show you really quick, data, right here you type in what confidence interval you want, and I had left mine at 95%, but you can type 80 or 100 or whatever, or 85, whatever the problem's asking for. In your case, it would be 80% for 8B, but I did 95%. That's why it says, let's hit cancel here. That's why it says cancel 95% here. But if you're finding that constant confidence interval, you need to know the mean of your sample, and then what it gives you down here for the 95% confidence level. Excel is printing out, this is the maximum error of estimation here, is 2.54. So remember what I've been talking about. The mean of our sample is right here in the middle, and if we do plus our 2.54709, that'll be the rightmost end of our confidence interval. And sorry, I was going to write it out here in Paint. So our mean's right in the middle of 15 point, what do we get? 15.3. And if we go 2.54 this way, what does that give us? About 17.84, so a little bit of rounding there. And then 2.54 this way, I'll use a calculator for that. 12.76. So with 75.76? Yeah, with 95% confidence, the mean is actually, for all the shards of clay, is actually somewhere between this number and this number. 95% confident. So again, using the data analysis, it gives you the mean, and this is E, or the maximum error, which you add on to get the right endpoint, and you do subtract to get the left endpoint. And somewhere between, the subtraction and the add, somewhere in between that interval is your, in my case, it's my 95% confidence interval.